I want to use this question 8 as an example. What we talk about when we think of the expected value is sort of the average value of the experiment going on. And so in this question, they say bag A contains 2 red and 3 green balls, and 2 balls are chosen at random without replacement, if that's significant. And X is to denote the number of red balls chosen. So here's our probability distribution. So these probabilities have been calculated out doing this experiment, drawing red ball and a green ball out of the bag. And this is telling me that 3/10 of the time you chose 0 red, 6/10 out of the time 1, and 1/10, 2 red, you chose 1/10 of the time. So they're saying calculate the expected value of X, which is the mean number of red balls chosen. And because our probability is written as a fraction, it's actually a little bit easier to put this into context and make it a bit more concrete. What this is really saying is that it's like you did the experiment 10 times. It's out of 10. And 3 of those times you got 0, 6 out of those 10 you got 1. And you could have done the experiment 20 times, 30 times, 40 times, but the probabilities reduced down and simplified down to these fractions. So if I were to ask you what was the average number of balls that you picked each time, you would be saying, well, the average is, well, 3 of the 10 times we had none. You chose none. 6 of the 10 times you got 1. So 1, 2, 3, 4, 5, 6. And 1 time you picked a 2. And again, we're thinking of this as a mean and average, so add these all together. 6 plus 2 is 8 out of the 10 times that we did it, so we're dividing by 10 because we have 10 numbers there, and we can say, right, that's 8/10. So the average number of red balls we took out was 8/10 of a ball. Again, it's this idea of what a mean or what an average is. So when we think of calculating the expected value, well, we've already said the expected value is the value times its probability. So 0 times 3/10 plus 1 times 6/10 plus 2 times 1/10. Well, we have 0 plus 1 times 6/10, 6/10, plus 2 times 1/10, 2/10, and we're at 8/10, which is the mean, the average number of balls that we chose. So that's where this idea of that the expected value is sort of like the mean value, the average value. I know I'm using average to mean mean, but the expected value is essentially the mean value of the experiment. On average, the mean number of times I pulled out a red ball was 8/10. I just want to go over this second part, B, to give you a bit of explanation of what you're supposed to do and how you will figure out the probability distribution. So now we're saying that there's a second bag that has 4 red and 2 green, and 2 balls again are chosen at random, and I want you to draw a tree diagram to represent the information and the probability. So I'm going to put it here, calculate the chance of it being red or not red. So the first chance would be 4 out of 6. Sorry, I'm not going to say red. Or green. So I have a chance of it being red or green. And so 2 out of 6 would be green. if I choose red, then it being red a second time is going to be 3 out of 5, because again, we're not going to replace the ball back. And for green, there's still 2 of them in the bag out of 5. So that's for green. And then if I pick a green ball first, there's still 4 red left over out of 5. And now there's only 1 green out of the possible 5 if I pick a green the first time. So this is what my tree diagram looks like. So the probability of each event, again it being a tree diagram, we just follow the branches and multiply as we go along. So over here, I'm going to, I know I'm writing, this is still part 1. The probability of 2 reds is 4/6 times 3/5. The probability of, and I'm going to do this slightly out of order, but green and green is 2/6 times 1/5, 2/30. The probability of red and green, and notice they don't distinguish about the order. So it's just a matter of, did I get a red or a green? And so there's 2 ways of doing that. Red first, green second, green first, red second. And so I'm going to multiply 4/6 times 2/5. And then we add that to 2/6 times 4/5. You might realize that essentially you're multiplying the same numbers together and adding them together, so I could just say 2 times the first probability, but we have 8 plus 8 over 30, so I have 16 over 30, and that should make sense because 12 plus 2 plus 16 should make up the whole experiment, and so yes, we have 30 out of 30. All right. So there's my tree diagram to represent the probability of each event. And now we're saying, hence, find the probability distribution for y, where y is the number of red balls chosen. And this is what I want to show you here. When you come up with your probability distribution, so we have y, and you can either choose 0, 1, or 2 red, and the probability of y, make this look like a diagram, is, so the chance of there being 0 red, well, that was green, 2 out of 30. The chance of having 1 red, and again, order didn't matter, we have 1 red, so we have 16 out of 30, and the chance of them being both red, 12 out of 30. And so there's how we create our probability distribution, and from there we can go on and answer some other questions which you will need for the other parts of this problem. I'm going to stop here with this because I just want to explain the first part and this part using the tree diagram to help you figure out the probability distribution. Okay? So I leave the rest of it for you to work on.